Hey guys, what's going on? Today we're going to be looking at 13.5, probability of independent and dependent events. So now you will see the word and because you were finding the probability of more than one event. So when there is more than one event occurring, you multiply the probabilities together, which again stems from the fundamental counting principle that we covered in 13.1. So probability of more than one event, math-wise, you can read it as the probability of event A and event B, which is equivalent of the probability of event A multiplied by the probability of event B. So there are two different types of probabilities in this case. We call them independent and dependent events, as you could probably guess by the name. So independent events are where the probabilities of one and the other are not really related. So whatever is picked is put back before the second pick. The denominator stays the same. A classic example of like an independent event is when you're flipping a coin, right? Each time you flip a coin, right, there's still two outcomes. So just because you get heads or tails on the first flip, that does not really affect what's going to happen on the second flip, right? The probability would still be the same. Um, Dependent event or where the events are related. Okay, so you don't replace, uh, you don't put something back essentially. So, like a classic example of this is if you have a deck of cards, right, and you're dealing some hands out, right? When you start dealing cards, you're not putting the card you just dealt out back in the hand, right? So that kind of affects the probability each time you deal a card out because now there are less cards to choose from. Okay, so independent and dependent events, but usually they're fairly intuitive, so you could kind of figure it out even if you don't remember which is which. So let's take a look at some examples. So out of a class of 20 students, your teacher chooses students at random to present their project. What is the probability that the teacher chooses you first and then chooses Kim second? Okay, so there's 20 kids in the class. You are one of those 20 kids. So first, the probability of you getting picked and you're getting picked in this scenario first. So you are one person and there are 20 people in the class. For the probability of Kim, okay, again, Kim is one person, and now there's a total students of 19 because you were already picked. So now there are 19 people to choose from. So all you do is multiply these together. So you have 1 over 20 times 1 over 19, and that gives you 1 over 380. Okay, so you can keep it as a fraction. Okay, so you flip a fair coin. We're on number 2. You flip a fair coin. What is the probability that it shows heads on the first flip and shows tails on the second flip? Okay, so the probability of heads is 1 out of 2, or 1/2. Probability of tails is also 1/2. Again, you're flipping a coin. It's not like you can put heads or tails back on the coin and then flip it again. It just stays there, right? Nothing's really decreasing. The coin is just the coin. And again, the probability of heads is not going to affect the probability of tails. So again, you multiply these together. So 1/2 times 1/2. 1 times 1 is 1. 2 times 2 is 4. So 1 out of 4. Okay, let's do another example. So Tom has 4 navy socks and 6 black socks in the drawer. One dark morning, he randomly pulls out 2 socks. What is the probability he will select a pair of navy socks? Okay, so in total, so the total amount of socks Tom has, 4 plus 6 is 10. he has a total of 10 socks. And starting off for our Navy. All right, so the probability when Tom first puts his hand in that drawer of him getting a Navy sock is 4 out of 10. 4 Navy socks out of a total of 6 socks. For the next event, okay, so now we're assuming, because again it says that he will select a pair of Navy socks. So we're assuming on the first go, he picks a Navy sock. So now there's a total of 3 Navy socks left. And there's a total amount of socks of 9, because again, he took one out. Multiply those together, that goes to 12 over 90, which can reduce to 2 over 15. Okay, and the rest of the examples follow a similar suit. So that is really it, guys. Thank you.